Hello everyone. Today we are going to learn about deadlock detection and recovery under operating system. It is one of the technique of handling deadlocks. There are four techniques of handling deadlocks, that is deadlock prevention, deadlock avoidance, deadlock ignorance, and last is deadlock detection and recovery. So in today's video you will be learning about deadlock detection and recovery technique of deadlock handling. So first we will see the introduction to deadlock detection and recovery technique. What exactly happens in this? It allows system to enter deadlock state and then recover from it. Your system will come into deadlock state and we will try to recover from it. That is called as deadlock detection and recovery technique is all about. Now what is the meaning of deadlock? Deadlock means process is infinitely waiting for some resource which he cannot acquire. So in that scenario, we call that process is in deadlock state. For example, this is my system and on my system there is a process running, suppose Word document, and I want to print that Word document. So there is a printer connected to my computer or system. So I want to print this Word document using this printer. So printer is the resource which I want to use currently for printing, and this is the process. Word document is my process. So this Word document process wants this resource printer, but it is not able to get printed from this printer due to some reason. It is waiting infinitely for this printer. Okay, printer is already printing some other documents from some other computers which are on the same network. So printer is not able to process the request made by this Word document. So in this case we say that this Word document process is in deadlock state. It will never be able to print itself. So that is called as deadlock. Process will occur in the deadlock state, and after it comes in the deadlock state we have to use the deadlock recovery algorithm to recover from the deadlock. So there are two algorithms used in deadlock detection recovery. One for detecting the deadlock, we use the detection algorithm, and then after detecting we have to recover from that deadlock, because deadlock is not a good thing to happen. If it has occurred you have to somehow recover from it. So for that we have to use recovery algorithm. Now first we will see how to detect the deadlock. Okay, there is a technique to detect the deadlock, that is resource allocation graph. By drawing the resource allocation graph we can easily detect the deadlock. If each resource type has exactly one instance and graph has cycle, then deadlock has occurred. For example, as you can see this resource allocation graph, this is called as resource allocation graph. We have a resources and we have a processes. Now whichever rectangles are there, those are called as resources, and these circles are processes. So there are three processes and four resources. So I have a resources R1, R2, R3 and R4, and I have a processes P1, P2 and P3. Now there is only one instance of R1. That is only one piece of R1 is there. Resource you can consider anything like a printer. Suppose R1 is a printer. Okay. Then R2 you can consider as a hard disk. R3 you can consider as a resource like CPU. R4 you can consider as a tape drives. So these are all the resources which are normally used by the computer. So there is only suppose one printer is there. Then you have R2 has two instances, means there are two hard disks are there. Instances are shown using this dot, black dots, as you all can see in the resource allocation graph. Then there is only one CPU. So R3 is suppose we are taking as a CPU, and R4 there are three instances of tape drives. Three tape drives are there. Now this process P1, P2, P3 you can consider as a Word, PowerPoint, okay. You can consider the Excel. All these processes are suppose running on your system. Now P1 P1 wants resource R1, that is printer, which is already taken by P2, and P2 wants R3. R3 we know it is a CPU, okay, and it is already currently taken by process P3. Similarly, P3 wants R2, that is hard disk, and that hard disk is taken by P1, and another hard disk is taken by P2. So P3 won't be able to take the hard disk in any case, because one hard disk is taken by P1 and another hard disk is taken by process P2. So there are no hard disks left for P3 to take. So P3 will wait for this hard disk R2. Similarly, P1 will wait for R1 resource, that is printer, because printer is taken by P2. Similarly, P2 process will wait for resource R3, that is CPU, because it is taken by P3. So all are waiting for each other for their resources to get released. See, there is a cycle made over here. See the arrow direction. This arrow is going over here, then it is going over here, then it is going like this, then again coming here, here, and then here. So it is closed cycle. If you see, it is becoming a cycle. Starting from one point like this, if you go in the direction, it will again coming to that same point. Okay, it is making a cycle, closed cycle. So if the arrow is going in the same direction and making a cycle, then we can definitely say that deadlock is there. So like this, you can draw the resource allocation graph using processes and resources, and you can easily tell that deadlock is there or not. Now this resource R4 is not used only by any processes. Nobody wants this resource R4, that is tape drives. But even if it is not required also, because of other resources, processes are in the deadlock state. Without using even R4 also, they are in the deadlock state. So like this, you can draw the resource allocation graph using your processes and resources, and you can tell whether deadlock is there or not. You can detect the deadlock. This is one of the way of detecting the deadlock, that is resource allocation graph. So if each resource type has exactly one instance, that is, suppose this is a resource R1, it has exactly one instance, and resource R2, it also has exactly one instance, and there are two processes P1 and P2. P1 wants R1, but it is already taken by P2, and P2 wants R2, which is already taken by P1. So you can clearly see the cycle has occurred, and only one instances are there. That is, suppose resource is suppose hard disk, there is only one hard disk is there. So either P1 can take it or P2 can take it. Already P2 has taken it, so P1 can't take it till P2 releases it. But P2 won't release. Why? Because P2 wants the resource R2, which is taken by P1. So both are waiting for each other to release their own resources, which is not going to happen. So in this type of scenario, we call it as a deadlock has occurred. So this is a resource allocation graph, which is drawn using processes and resources, which can easily tell you that deadlock has occurred. See, it is going in this direction. See the arrow going in same direction and coming to the same point. So cycle has occurred, and there is only one instances of both the resources are there. So 100% there is a deadlock. It implies if cycle involves only a set of resource types, each of which has only single instance, then deadlock has occurred. So therefore, cycle in the graph is both necessary and sufficient condition for existence of deadlock. If there is a cycle in the resource allocation graph, now this is the resource allocation graph. If there is a cycle, you can 100% tell it is a deadlock. Okay, so for detecting the deadlock, cycle is a necessary and sufficient condition. So in this above graph, you can easily tell that it has a deadlock. So there are two types of graph we normally draw for detecting the deadlock, that is resource allocation graph, as you can see in figure A, and there is a wait for graph, as you can see in the figure B. Now resource allocation graph, there are resources and processes shown. In the rectangle, all are resources, and whichever are put up in the circle are called as processes, and they are connected using arrows, line with the arrows. So that is resource allocation graph. In the wait for graph, only processes will be shown and the line with the arrows. Processes which are waiting for the other processes to release their resources. Okay, and you can show the cycle using wait for graph also, but the resources you can't show in the wait for graph, that you can show only in the resource allocation graph. So mostly we use resource allocation graph for detecting the deadlock. Then we have seen how to detect the deadlock using resource allocation graph, wait for graph. Now we'll see how to recover from the deadlock. Deadlock has occurred, we have detected also, but how to recover from that deadlock, that we'll see now. Now one way to recover from the deadlock is what? Process termination. You can terminate the process. Like this system is connected to this printer resource, and this printer resource is required by all these processes. Now 5 processes are running on my system, that is they are open on my system, that is Word, PowerPoint, Excel, Project and Microsoft Visio. all wants to get printed using this printer resource. But printer is not free and they are waiting for the printer. All are waiting infinitely for the printer. So they all are in a deadlock state currently. So what is the one step to recover from this deadlock? You can terminate the processes only. Abort all deadlock processes. That is, close all these deadlock processes. That is one way to recover from deadlock. Or you can do only one process abortion. That is, only one process you abort or close at a time until deadlock cycle is eliminated. Then how you are going to abort the processes? You need to find out the order. Which one you will abort or close first out of these 5 processes. You can abort based on the process priority. Whichever is more important, that you keep it. Like word is more important. I want this word document to get printed. It is very important document. I want it to get printed. So keep that word document open, and rest all the processes you can abort or close because they are having low priority as compared to word. So based on process priority, you can abort the processes. Then how long the process has computed and how much longer to completion. Suppose you have already printed almost 4-5 pages of Word document, only one page is not printed. But other documents have not even printed one page of their document. So in that case, you can keep Word. You have to see how long the process is already computed and how much longer it is required to complete. You can also consider how many times the resources are used by this process. That is how many times printer is already used by these processes. If Word has already used the printer many times, you can give chance to other processes to use printer like PowerPoint, Excel, Visio, project. Okay, so based on that also you can terminate the processes or abort the processes. Then resource process needs to complete. How many resources are needed by the process to complete? Based on that also you can terminate the process. Then how many processes will need to be eliminated? If there are not many important processes running, only word is important suppose and all other processes are not important, you can abort those processes. Okay, that you can decide. Then you have to find out, is the process interactive or batch process. Based on that also you can terminate the process. So all these are the ways in which you can find out the order to abort the processes, because you have to terminate the process in order to recover from deadlock. Otherwise you won't be able to recover from deadlock. Process termination is one way of recovering from deadlock. Then you can select the victim to minimize the cost of recovering from deadlock. You can even roll back, that is return to some safe state, restart the processes for that state. Or you can use the starvation, that is same process may always be picked as a victim, include number of rollback in cost factor. Then second way to recover from deadlock other than the process termination is resource preemption. You can preempt the resources. That is suppose this resource is already printing some other type of document. Suppose your Gmail document. Okay, you can just hold it for a while and you can give the printer to this Word document so that this Word document will get printed. So you can preempt the resources. If it was printing the Gmail document, you can give the stop it and you can give the control to Word document. Okay, so you can preempt the resource. So resource preemption is one way of recovering from deadlock. Then third way of recovering from deadlock is ostrich algorithm. That is, just ignore the deadlock. That is also one way of recovering from deadlock. You just have to ignore the deadlock as if it has not occurred only. So these are the 3 ways of recovering from deadlock. One is process termination, second is resource preemption, and third is ostrich algorithm, that is ignore the deadlock. So you can abort all the deadlock processes and reclaim the resources, or backup all the deadlock processes to predefine checkpoint and restart. Or you can gradually abort processes in deadlock one by one until deadlock is resolved. Either you can abort all the deadlock processes and start the work again because deadlock has already occurred. You have to recover. Or you can abort one by one the processes based on their priority or other mechanism you can use to abort the processes one by one until the deadlock is resolved. Okay, or you can back up all the deadlock processes to predefine checkpoint and restart. So these are the ways of recovering from deadlock. Or you can successfully preempt the resources until deadlock is removed. Okay, you can go from one process to another. That is called as preempting. So resource can go from one process to another. So resource is getting preempted. Now combined approach for deadlock handling is, there are three combined approach: prevention, avoidance and detection. You can combine all these three things to handle the deadlock properly. You can use the deadlock prevention, deadlock avoidance and deadlock detection together to handle the deadlock properly. Allow use of optimal approach for each of the resources in the system. Partition the resources into hierarchically ordered classes and also use most appropriate technique for handling deadlock within each class. So these are the combined approach to handle the deadlock. So this was all about deadlock detection and recovery technique under operating system. Thank you.